My name is Vijay Suraj and my matrix number is 22300135 and my partner's name is Kishendran. His matrix number is 22300095. Today, Kishendran and I will be presenting the signal conditioning system we developed to optimize our MQ2 smoke detector. When interfacing the MQ2 directly to the Arduino, we faced several vulnerabilities. High frequency environmental noise like 50 Hz EMI from power lines creates voltage spikes that easily pushes a clean air signal over our 2.5 volt software threshold, causing false alarm. We also face impedance loading issue and the raw noisy signal caused terrible threshold shattering, which rapidly strains the alarm components. To permanently resolve this, we engineered a two-stage hardware solution. Stage 1 is an LM358 operational amplifier acting as a buffer. Stage 2 is a 1 Hz passive RC low-pass filter to aggressively clean the data stream before it hits the Arduino.
Okay, in clean air, the MQ2 has extremely high internal resistance. This creates an impedance mismatch that struggles to charge the Arduino's ADC. By using the LM358 operational amplifier, we utilize its near infinite input impedance to read the sensor voltage without drawing current. It perfectly protects our voltage scale while providing the low output impedance needed to drive the rest of the circuit. Stage 2 is our RC low-pass filter. Since actual smoke diffusion is a very slow physical process, we set our hardcore cutoff frequency precisely at 1 Hz. This allows the genuine slow voltage changes to pass straight through the Arduino, while violently flattening the rapid 10 to 15 Hz spikes caused by the environmental noise.
To achieve that exactly 1 Hz cutoff, component selection was critical. Using the cutoff frequency formula, we started with a standard 10 microfarad capacitor, which requires a 16 kilo ohm resistor. We deliberately avoided smaller capacitors because pushing the resistance higher would introduce Johnson-Inquist thermal noise. This 10 microfarad and 16 kilo ohm combination was the perfect balance. The mathematical results are exceptional. Testing the filter's transfer function against a standard 50 Hz AC power line hum gives us a voltage gain of just 0.02. That is negative 34 decibels of attenuation. Our hardware blocks 98% of power line interference, turning a massive volt spike into an invisible 0.01 volt ripple.
Okay, finally, looking at the time domain, our filter creates a time constant of 0.16 seconds. While a fraction of a second is completely negligible for a smoke alarm, it acts as an absolute shock absorber for electrical transients. The result is clean, averaged signal that crosses our 2.5 volt threshold decisively, completely eliminating threshold shattering. Thank you.
Thank you.